Good afternoon and welcome to the Embedded Executive Podcast. My name is Rich Ness and I am the Executive Vice President of Open Systems Media. I lead the embedded and IoT teams for embedded computing design. My guest this week is Chet Babla. He is the Senior Vice President at Indie Semiconductor. How you doing, Chet?
Yeah, very good, Rich. Really happy to be here today.
Okay, well, I'm happy to hear that. Before we get what we really want to talk about, just to be sure everybody knows who Indie Semi is. Who is Indie Semi?
Yeah, so Indie Semiconductor is obviously a semiconductor company, and we develop solutions specifically for the automotive market. So if you look at the three big mega trends in automotive today, electrification, in-cabin user experience, and driver safety and automation, they're the three areas that we develop silicon for. We're listed on NASDAQ. We've shipped over 300 million chips into automotive. And just recently, Morgan Stanley stated that we were the fastest growing semiconductor company over the last 2 years. So we're really pleased for that shout out by Morgan Stanley.
I did not know that. And where are you guys based?
Orange County is the headquarters, but we have global offices.
And why is the name Indie?
Yes, there's a good story behind that. A couple of things. Actually, we want to be an open platform. We want to work with everyone. We don't have we have an open software approach. So let our customers bring their innovation. And also, originally, the founders were big fans of the movies, and especially independent movies. So it was just an interesting way to bring in these multiple elements into the name.
Okay, I'll buy that. So you talked about three different facets of the automobile, and the computing requirements for those three different facets are very different. So are they developed by, does the company have a separate team for each of those areas? Or are you trying to use the same fundamental design techniques, that's the wrong word, but for each of those three different aspects?
Yeah, great question, Rich. I think the company's foundation and strength really is mixed signal semiconductor design. So the analog, the digital, all of those different elements, bringing those together, integrating those. But you're right, if you look at the needs for some of the electrification space, very different to what we need in ADAS. So we are kind of organized as business units focusing on these different areas. But there's some fundamentals that you need across all of the different segments. So you'll find microcontrollers everywhere, right? So we have that as almost like a modular capability, and we make good reuse of it across the different segments. But if you look at say in-cabin user experience, the requirements for lighting are very different, say, to what we're doing in the ADAS space,
right,
where we develop, say, vision processing or radar or LiDAR processors. So yes, very different design approaches and functional blocks that are needed.
I should know the answer to this, but what instruction set are we talking about?
So we use ARM-based solutions.
Okay, all right. I have seen Indie Semiconductor used in the same sentence with the term the uncrashable car.
Right.
So I'm going to hold you to that since you're representing the company here. Does that refer to a physical crash or a software crash? And then you need to defend it.
Right. So what we're really talking about here is accidents on the roads.
Physical crashes.
Physical crashes. And we're very passionate about. I mean, everyone knows about the number over 1 million people die on the roads every year. It's terrible. That's 3,000 a day, over 100 a day in the US alone. And we are seeing some of the higher end luxury premium cars increasingly including some of these ADAS sensing capabilities, which is great. And they can help to mitigate some of this terrible fatality that we're seeing. But, we're very passionate about bringing that ADAS safety sensing to the mass market. Why should it just be the preserve of expensive luxury cars? So our vision really is, and the uncrashable car, you're not going to get there today. You're not going to get there tomorrow. It's going to be a multi-year, multi-decade struggle. But we want to start bringing some of that sensing capability down into the mass market vehicles. So everyone can benefit from it and it can quickly start to drive down this terrible death toll.
So to be clear, you're referring to the sensing technology for the most part, right?
That's right. Yeah.
And is there something in particular that you're referring to? Is it LiDAR? Is it radar? Is it something else?
So if you look at the key kind of ADAS type of sensors that you see in vehicles today, it's radar, long-range radar, cameras, long-range cameras, the ultrasonic detectors as well, which sometimes get left out, and the new emerging LiDAR technology. And then within those, there are different use cases, different kind of external to the vehicle use cases within the vehicle use cases. So we're developing solutions. I think we're probably the only chip company that's got silicon solutions for all of those 4 sensor modalities.
So you're designing the sensors themselves.
So we've designed the processing element, not like the camera sensor. We're designing the image signal processing, the video processing, or the radar processor itself.
Okay. So how do you differentiate from your competitors? Because if it's ARM, everybody's got ARM.
Yeah. So I mean, if you look today, you know, there are multiple compute elements, processing elements you need in a chip. The MCU, the CPU is one element, and it's great for certain types of processing. But if you look today, for example, in our vision processors, we have image signal processing that we've developed ourselves. We've got geometric processors we've developed ourselves to help de-warp some of the fisheye lens processing. So there's, and if you look in our LiDAR and radar chips, we deploy DSP and develop our own algorithms around that. So, you know, the CPU is just one element of kind of some of the housekeeping interfacing. Actually, there's additional processing elements that you need, and that's what we're really expert at deploying and developing solutions around.
And how much of that comes down to sensor fusion, where you're actually integrating like sensors and unlike sensors into the same module, I'll say, not into the same piece of silicon, maybe?
Yeah, so a great question again. So if you look today, by and large, most of the sensor deployments are individual sensors. So the camera will be deployed perhaps behind the windshield. The radar might be there in the front grille. You might have some detection in the mirrors. We are just starting to see now the industry is saying, hey, there's got to be another way of doing this integration. Can we integrate radar and camera? When does LiDAR come into the picture? So as a company, we are at that stage of saying, hey, we've got a great handle on these individual sensing processing. What is the next step in terms of fusing some of those sensor processors? We actually had a white paper recently where we were showing some of our early work on radar and camera sensor fusion as well. So for sure, it's definitely the next stage the industry is going at. But we also got to look at some of the EE architectures in vehicles and, you know, make sure that we're designing in the most efficient and cost efficient way and power efficient way.
But you can only be as successful as you can convince your customers to incorporate this technology. Where do they stand? Are they, you know, they're about as conservative as it gets when it comes to bringing in new technologies? What are those discussions like?
Yeah, absolutely. This is a conservative industry, and rightly so, right? If you get things wrong, unfortunately, there's bad consequences. So we've been having a lot of discussions with OEMs and tier ones. I think if you kind of rewind the clock 2-3 years, there was this big kind of hype around a big central compute in the car, and you'll have sensors, dumb sensors, sending raw data to this Uber computer, if you like. And actually, and if you fast forward to today, that hasn't really happened. Maybe there's the odd EV only company or the, you know, robotaxi companies that are going down that route. But from a mass market deployment, you know, people who've got everything from a city car to a luxury car in their portfolio, a single Uber computer doesn't really meet the needs of their models. So we've started to see discussions with OEMs. People are talking about more distributed compute. We call it distributed intelligence. OEMs are saying, hey, you know what? We do need some processing closer to the edge, maybe in the zone proximal to the sensor. Hey, Indy, what are you guys thinking around that area? You've already got the processing for the individual sensors. Can you do a little bit of the processing closer to the edge and send us less data to our domain controller? And that has benefits in terms of, well, one, you're shipping less data, there's less speed you need to deal with. Amazing stat was the wiring contributes about a third of the cost and a third of the weight in vehicles today, right? So if you don't need to support a lot of high speed data, that has multiple benefits. So we're definitely seeing from OEMs, they're starting to see zonal processing as being a next step rather than this, wonderful vision of a central compute.
So I'm a little confused by that. So you're saying that there shouldn't be one central compute point at all. So the sensors in the front aren't talking to the sensors in the back, for lack of a better term for now, that they should be completely independent?
No. What I'm saying is some pre-processing of sensor data makes a lot of sense. So perhaps
got it.
you
Okay.
take the radar and camera information and perhaps you do as much as object classification, maybe not detection, or maybe you do some detection, but then the interpretation of that for the vehicle to then make a decision is done in the domain controller or more centralized compute.
Well, I got to tell you, that's a pendulum that just keeps going back and forth, because when I was at Embedded World not too long ago, somebody introduced a solution that is, they want it to be the single compute box in the car. Give me all your data and let me all handle it. And they claim to reduce many of the cable and the weight in the car by doing that. Very interesting discussion, and I can make the argument in either direction.
Yeah, I guess if we look at what's actually happening in EE architectures today, that generally isn't where the industry is going, certainly for the next five years.
Is it geography based as well? Are the Europeans looking at things differently than they are in Japan as they are in the US, or do we seem to be all coming to the same vision?
I think if you look at the quote unquote mainstream OEMs, they're all kind of starting to say actually perhaps some zone edge processing makes sense. As I mentioned, that you will see some, if there's an OEM that's only EV, doesn't have a great huge legacy to support, then perhaps looking at a more centralized approach might make sense. Or a robo-taxi company where the business model is totally different to someone actually buying the car. It's been well documented. Folk are looking at that, but I think for your average kind of passenger car OEM, that's kind of the trend we're seeing today.
Very interesting, Chet. I am really anxious to see how all this plays out, and it sounds like it's going to be sooner rather than later. Do you agree with that?
I think so. I think how regulation is driving the need for more sensing and the complexities of trying to integrate all of those sensors, for sure, people are saying, well, okay, what's the right kind of EE architecture for me to get there quicker rather than wait longer for, this vision of a central compute.
Very good. Thank you very much, Chet. I appreciate spending some time with me.
Great to talk with you, Rich.
That was Chet Babla. He is a Senior Vice President at Indie Semiconductor, and I'm Rich Nass with Open Systems Media.